Welcome to the trials and tribulations of my 8-bit breadboard computer build. So we just finished the first part, which is building the clock module, and now we'll be moving on to kit 2, which is the registers in the ALU. As you can see, this is the pamphlet that comes in kit 2. It gives you a summary, a list of parts that come in the kit, as well as a schematic and information on the chips and logic gates, and an overall picture of the completed project. So we'll be building 3 8-bit registers, A, B, and the instruction register. Both A and B are general purpose registers, while the instruction register will only store the current instruction that's being executed. We will also be building the arithmetic logic unit, and usually that is capable of performing various arithmetic bitwise and comparison operations on binary numbers. However, the one we will be building will just be able to add and subtract. It's connected to the A and B registers, and the outputs either the sum of A plus B or the difference of A minus B. So again, we'll be building the A register, B register, instruction register, and the ALU. So here are some screenshots that I used to help me while building the A register and the other registers, since they are kind of identical. I'm such a novice builder that the wiring can get a bit messy and complicated, so this helped me a lot. So here I am working on testing the A register that I've built, which is part of kit 2 out of 4 of the Ben Eater's 8-bit breadboard computer build. So we're going to go ahead and get this hooked up and tested to see if the register is working accordingly. To test the A register, we will set our load to low. It's connected to the pin on the chip that enables us to load data onto our register. Looks like it's working. So when we set the load to low, the next time the clock goes high, all of our bits in the A register go high as well. They are each loaded with 1 bit. So by default, we are getting 1. So we want to go ahead and test loading data into the register or loading an input into the register. And I pretty much followed everything in the Ben Eater's YouTube videos, which I suggest you go and watch. They're very helpful and detailed. So here I am just going to go ahead and start testing the A register, make sure that's working accordingly, and putting information on the bus as it should be. And making sure that it's getting data from the clock pulses, or if we're going to go ahead and manually input it in. Here we are using the bus to input data into the A register to make sure everything is wired up correctly. So we're setting bits either to 0 low or to a 1 high, and then that can also be a numerical number in decimal if we translate it from binary to decimal. So we're going to go ahead and test out and make sure that the register is working well and loading onto the bus as it should be doing correctly. So here, let me go ahead and just start putting in some of those. So as I put them in, it's going to go ahead and turn this one off, giving us a 0, and the rest will remain 1. And here we'll go ahead and do another input here. Okay. So it looks like it's working correctly. Let me do the first one as well. All right, so we have the 2 first ones, and then the one next to that is off. Okay, and then now we're going to go ahead and load this onto the bus with our enable here. And it looks like it is matching and corresponding. Now, what happens when we take this? Now it has been loaded onto the bus. Is it going to save the data? That's what I want to know. But it looks like everything is good still. Okay. So when I did this before, one of the lights switched to 1, which was not good. They need to be staying at the original input values that we did, which was 0, 0, 1, 0, 1, 1, 1, 1. And so here it's the same, so that's good. So just finalizing testing of the correspondence between the register and the bus, making sure they're displaying the same values. Here we have a close-up of the bus, which you can see it matches the close-up of the A register. So everything looks good. So here is a close-up of my A register hooked up to the clock and the bus that we were using for testing. So you can see it a little bit better here, the wiring and whatnot and how everything is set up. I'm sure it's going to change over time as I progress with the project, but for now, this is what my A register looks like. Now that the A register has successfully been completed, we will move on to the B register of part 2 for the 8-bit breadboard computer.